we have the whole rest of this formula sheet that we didn't look at yet. So from here all the way to here, these two bottom ones and the top ones we've looked at, right? The rest are all new. We agree? That's this unit, all these. Now, what's great about them? They're given to you. You don't have to memorize them. That's fantastic, right? So stuff you don't have to do. Now, whenever I say exact values means no decimals. We agree? Yes. He came up to me, he's like, so what decimal place do you need exact values to? I'm like, not a decimal. He's like, that was my tricky question. Way to ask if it was a decimal or not. Exact value means no decimal places, okay? Exact value majority of the time, like 99.9% of the time in trig, means I'm asking you to go to your unit circle. Pull values off the outside. It's a hint most of the time, okay? So this one says, previously you were asked to find exact values. Now wherever there's these little y's, those are degree symbols. Just wingdinged them into a y, a fancy y. No, I agree. No, just no. The y becomes a little degree symbol. If you're like, I don't have these notes, you do. I just gave them to you. So go find them. Okay? And then tan of pi over 4. So if I gave you sine of 30, what would we do? How would we get an answer? Go to our unit circle. Go to the 30 degrees. Give me the y, Calgary Stampede, right? Go to the 30. Give me the y. The y is a half, so that's my answer. Boom, done. Tan of pi over 4, what did I do? Go to pi over 4. Tan is y divided by x. So it's root 2 over 2 divided by root 2 over 2, which is actually just 1. All the 45s for tan are positive or negative 1, depending on what quadrant they are in. Okay? But what if I give you sine 75? I ask you for the exact value, so I'm still asking you to go to the unit circle and pull values off. However, sine 75 is not on the unit circle, is it? Is the 75 on there? No, on the unit circle we have 0, 30, 45, 60, 90. Right? We have reference angles of 30, 45, 60, and 90. So there's got to be a better way. Yeah? You can add 45 to the 30. So we can write it like this. Bless you. I could go 45 plus 30. It would make no difference because of the plus sign. We agree? Remember how I said you can't flip angles, but you can flip answers, and I said it 700 times. You didn't believe me, but now you do. This is another instance where you're not going to believe me and you're going to do this wrong. You cannot distribute the sign in to these brackets. You cannot write sine 30 plus sine 45. If you're like, I'm so going to do that, write yourself a little note with a big old star, possibly highlighted 8,000 times. I don't know how you'd highlight it. It would go away. So highlight only once or twice. 8,000 times would be pretty dark. And write, do not distribute the sign in. Use the formula. Do not distribute the sign in. Use the formula. And if you're like, I'd never do that. You flipped angles when I told you not to. You will distribute. It's like you've been taught since grade 9, put into brackets. So it's like a part of your being to want to put that in. I know it is. Trust me. I get it. I see something outside bracket. I want to put it in. Okay? You can't. Now, why can't you? Sine of 30. Sine of 30. If you did that, which you can't do this. Sine of 30 is a half. Sine of 45 is plus root 2 over 2. The answer to this is 1 plus root 2 over 2. Do you agree? If I did this? This equals this equals this. Okay? So that's if you had distributed it. That's the answer you'd get. You'll sine 75 in your calculator. What mode do I need to be in? Because I'm pressing sine. Oh, I'm viciously just holding a marker and putting dots on here. Oh, I have my other marker out. It's bad. So we go sine 75, and I make sure I'm in degree mode, which I'm not. That. Okay? What was my answer on the previous page? So 1 plus square root of 2 divided by 2. Dang it. They don't match. What? Yeah, they don't match. So therefore you can't do that because it's not right. It's bad news bears, okay? So I just literally proved to you it doesn't work. So we're not going to do that, okay? It doesn't work. You get an answer. It's a wonderful answer. It's 1.2. Like, that's a pretty nice answer, isn't it? It's totally wrong. But you'd put it and be happy because you're like, bam. And what do you think they're going to have for an answer? That, because that's going to be common error. Okay, we're not going to do that, though. We are going to be good and not do that because that's just silly. So this is not equal to that, is not this bad. Do not do. Okay? We agree? We saw. It doesn't work. So there is a formula on your formula sheet, however, that does work. Sine A plus B. So wherever we have an A, we're going to put 30. And wherever we have a B, we're going to put 45 into the right-hand side. Okay? So this actually equals sine of 30 cos of 45 plus cos of 30 sine of 45. Now, what I need you to do is sine 30 is going to go in brackets because it's all connected. You agree? So I'm actually going to put these in brackets and hope that I don't do the next common error that happens. Haven't put those in brackets. Okay? What is sine 30? Do not type it in your calculator because I said I want what? Exact values. Exact values, a hint, go to my unit circle. Okay, unit circle, bestie, should be out. You're going to be using it a lot in this entire unit. Sine of 30 is a half. We have it up here. So this whole sine 30 equals what? A half. Now, what happens if we don't know how to do sine of 30? We actually can't do this entire question, right? Remember that little question I gave you? If you can't do it, you can't do this. Now, I'm going to tell you right now, so many people, if they don't put brackets around sine of 30, cos of 30, etc., write sine half, and then give me this crazy decimal at the end. You guys just don't get rid of the sign. You're like, sine of 30, oh, it's a half, sine half. It happens all the time. You just carry that sign through. No, it don't, okay? And you're like, that won't happen. It does, a lot, all the time. I see it, okay? Like half of you will do it. I'm hoping that telling you this, that reduces that half to a smaller fraction. Okay, so sine of 30, the whole of sine of 30 equals a half. Cos of 45, root 2 over 2. Plus sine. Cos of 30, root 3 over 2. Sine of 30, or sine of 45, sorry. Root 2 over 2. Okay, we're bringing back rules. When you multiply radicals, you multiply the outside by the outside and the index, so it's underneath the radicand, sorry. It's under the radicand, so it's under the radical by what's under the radical. If I multiply two radicals that are the same together, what do you get? So like, for example, root 2 times root 2. It's just 2, because root 2 times root 2 is actually root 4, which is 2. So when you multiply two radicals that are the exact same together, you just get the number. So root 2 times root 2 is 2, because root 2 times root 2 is root 4, which is 2. Okay? Knowing that, let's move on. So we're going to multiply these. 1 times root 2 is just root 2, right? 1 times anything is itself. Then people write 2, and I do this myself all the time. It's like a habit. What's 2 times 2? 4. I write 2 all the time. Just because you're like, oh, 2 2s, common denominator, boom, 2. No, it's not. 2 times 2 is 4. Plus, root 3 times root 2 is root 6 over 4. What's great about these addition and subtraction formulas? They always get you common denominators. You never have to make them. Sweet. So you're just going to get root 2 plus root 6 over 4. And you're done. Why are we done? Why can't we add root 2 plus root 6? What's the rules about adding radicals? Remember? You have to have the same radicand. Whatever's underneath the radical has to be the same. So it's like trying to add a 2x plus an x squared. Can we add those? No, it's the same as trying to add a root 2 and a root 6. They're not the same. Okay? It's like an x and a y. We're done. Okay, let's try this out. Root 2 plus root 6 divided by 4. See, it is beautiful, isn't it? I know, you never thought math would be beautiful, but there's a connection. It's quite wonderful. Okay? We get it? Can we just distribute in and be like, boom, this is so easy? No, we can't. Bad. Very bad. Okay? Make sense? That right there, just beautiful. So when you do these, can you not just check your answers? Yes. So do you think they put this in a multiple choice? Probably not, because you could just go sine 75 and all your and match and do nothing. Probably more so of like a root a plus root b over 4, what's a plus b, or ab respectively, or blah, 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 right? Okay. Sine of pi over 12. Pi over 12 is confusing because it's radian measure. Can I change it to degrees and then just use degrees? Yeah, does it matter? Does like sine 35 and 4 plus 45 or pi over 6 plus pi over 4, does it make a difference how I get my answer? No. So what is pi over 12? 15? So this is just sine 15. What would I do in this case now? 15 is not on my unit circle. They want exact values. What is on my unit circle that could get me 15? 45 minus 30. Plug it into your formula that is at the top. Try it out. Okay, we're going to get sine cos minus cosine. Close, yeah. Okay. So you're not actually putting in a negative angle at all, are you? You're just filling, this is your A, this is your B. You're filling it in for those spots, right? And the minus sign just gets you a minus in between on this particular formula. Sine of 45 is root 2 over 2. Cos of 30 is root 3 over 2. Minus cos of 45 is root 2 over 2. Sine of 30 is a half. So you're going to get root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 over 4. I'll go right back in a second. And they match, so we know we're good. Grab out a separate sheet of paper. When we do the tans, we need space. So we'll do tan 165 and then we'll do tan 75. We'll do tan 165 first. Okay. Does anything add to give me 165 on my unit circle or subtract? 120. Why did you pick 120 plus 45 and not like 105 plus 60? No, you were right. No, you're right. Why wouldn't you pick 10, 105, and 60? 105 is not on the unit circle.
Yeah, it's gotta be obvious.
Okay, so we have to pick stuff that's on the unit circle when it says exact value. If it didn't say exact value, we could literally just go tan 165, give me a decimal, right? So exact value means I can't use decimals, so I can't just go tan 165. And they're not testing whether you can press a button, okay? Okay. Tan formula is awful, and it is, I'll write it on here, tan A plus B equals tan A plus tan B and I always put these in brackets just so I make sure I replace the whole thing. 1 minus tan A tan B. Now I'm going to give you a hint to tans. So sines and coses you can just pull directly off your unit circle, right? Super easy. Tans you have to do that extra little step because you have to do y divided by x. We agree? So I do all of those off to the side first before I input them into the formula. The formula is ugly enough as it is. You don't want to go trying to like reduce a radical divided by another, like that's just awful. So I do it off to the side. So I'm going to fill the formula in first and then I'm going to do my math off to the side. So it equals tan of A. A in this case happens to be 120 and B 45. Had we switched them, then the one would be B and one would be A. They would be the opposite. And we could still use them because it's plus, right? It's only minus where it really matters what order you have them in. So we're going to do tan 120. Oh, good. Let's back to that. Plus tan 45. Tan 45 is a nice one. It's just 1. 1 minus tan 120, tan 45. So off to the side, I'm going to find tan 120 and tan 45, so I don't have to go try and do that math in this ugly fraction as it is. Okay? So tan of 120 is y divided by x. What's y at 120? Root 3 over 2. Y? Yeah, I'm thinking 30-degree reference angle. So y is root 3 over 2, and x is negative 1/2. So you're going to get root 3 over 2 times negative 2 over 1. 2's cancel. I'm left with negative root 3. So now for every 120, I'm going to fill in negative root 3. Tan 45 we said was 1. And it is because y divided by x at 45-degree reference angles is the same x and y. Just the sign is different, whether they're positive 1 or negative 1. So it equals root 2 over 2 divided by root 2 over 2, which is 1. We agree? Everyone following? So on the top here, this tan is actually one of the nicest tans because this tan doesn't have any fractions, right? When we do tan 75, we're going to get like a fraction plus a fraction over something, yeah, different ballgame. So here we're going to get negative root 3 plus 1, which I like writing as 1 minus root 3 because I like having the positive first. On the top, these two are multiplied together. What's negative root 3 times 1? What's 1 minus a minus root 3? 1 plus root 3. And you're all like, yay, I'm done, except no, because they're going to rationalize the denominator. What does rationalizing the denominator mean? It means we're going to get rid of the radical in the denominator. In grade 11, do you remember how we did that when we have a binomial in the denominator? If you just had a radical like root 3, you just multiply by root 3 and it would go away. But you have to do it to the bottom and to the top. But when you have a binomial, you have to multiply by the conjugate. So that just means exact same numbers, opposite sign. So because I want the bottom to go away, the bottom is 1 plus root 3. I'm going to multiply by 1 minus root 3. Now, why does multiplying by the conjugate get it to go away? Multiplying by the conjugate is opposite signs, we agree? So they're the exact same but opposite signs in the middle. Let me show you over here. If I go 1 plus root 3 times 1 minus root 3, I get the first times the first, which gets me a number, 1. But what happens to the middles? They're actually the same but opposite signs, and they're the only ones that keep a radical. So we're going to get minus root 3 plus root 3. What happens to them? They cancel off. The reason why you multiply by the conjugate is it gets rid of those middle terms that have radicals. If you multiply by the same thing, so you forget to switch the sign, your middle terms are not going to go away. They're both going to be plus or they're both going to be minus. And then the last one goes away because why? What's root 3 times negative root 3? Negative 3. Because it's actually negative root 9, which is 3. And in the bottom here, I then have 1 minus 3. And my radicals are gone. And I rationalize the denominator. That's why you multiply by the conjugate. Because it gets rid of those two middle terms that do have radicals that you can't get rid of. Okay? Make sense? You learned that last year. Okay. Then we're going to do the numerators. 1 times 1 is 1. 1 times negative root 3 is negative root 3. 1 times negative root 3 is negative root 3. Negative root 3 times negative root 3 is positive 3. The middle ones didn't go away this time. Does that matter? No, you just have to rationalize the denominator. Now remember, we said that we can only put together radicals that have the same radicands, what's underneath the radical sign. Just like if we had 2x plus 3y, it would not be getting put together. But if I had 2x plus 2x, I'd have 4 x's. We agree? Right now, if you read it properly, you'll remember how to do it. So I have a negative 1, I have negative 1 root 3, and I have another negative 1 root 3. So what do I have? Negative 2 root 3. And then I have 1 plus 3. I have a 4 over negative 2. We're not done. You also did this last year. If you can take a number out of every single term, what's a term? A term is something that's connected by plus or minus signs. If you can take a number out of every single term, you do it. So there's something I can take out of 4 and negative 2 and negative 2. Better than that? Yeah. So I can take out a negative 2. So 4 divided by negative 2 is negative 2. Negative 2 divided by negative 2 is plus 1, and it stays there. Negative 2 divided by 2 is a plus 1. Do I need to keep a positive 1 in the denominator? And what if it was in the numerator? Yeah. Ooh, plus sign. Ooh, don't like that. So albeit this answer is correct before, that will not be on your diploma. This answer will be. But worst case scenario, say you forget how to reduce it. If it's a multiple choice, what could you do? Compare the two. Will this be a multiple choice? Probably not, because you could have just went tan 165 and turned your answers into decimals, right? Okay. Okay. Last one we're going to try is tan 75. You need a whole sheet of paper. Sorry about your luck. If you write small, you probably won't need a whole one. If you write average, you're going to need quite a large, the whole page. Well, it'll get close because it's fractions over fractions. Yeah. It won't be so bad. You'll be okay. Okay, tan 75, what can we put together? What if it was cotan 75? What would you just do? If it was sine of 30, you'd go to 30, you take sine, you give me an answer. If it was cosecant of 30, you'd go to sine, you get your answer, and you do what to your answer? Flip the answer, because you can flip answers, right? So tan of 75, we just do it into the formula. But if I gave you cotan 75, what are you going to do? Find tan 75 and flip it. That's it. Yeah, yeah. So tan 45, and then we'll do cotan of 30. Tan 45 is tan 30 plus 45. To be honest, it's the 30 that's the issue, not the 45. 45 is still 1, right? So when we fill it into the plus formula, we get tan 30 plus tan 45 over 1 minus tan 30 tan 45. So we can flip answers, but we can't flip angles. That has not changed. It won't change for life, actually. It stays that way forever. And Trig. Off to the side, I'm going to find tan of 30. Tan of 30 is y divided by x. What's y at 30? What's y at 30? 1/2 divided by what's x at 30? So we're going to get 1/2 times 2 over root 3. 2's cancel. And we get 1 over root 3. And I would not put 1 over root 3 into my fraction if I can get away with it, or you're having to make common denominators with radicals. So I'm going to rationalize the denominator before I put it in. So in this case, I just multiply by root 3 because it's a monomial in the denominator. If I have a binomial, I have to multiply by the conjugate. But if I have a monomial, one term, I just multiply by the radical. So I get root 3 over 3. And what's tan 45, did we agree? 1. So I'm going to get root 3 over 3 plus 1 over 1 minus root 3 over 3 times 1. which gets me root 3 over 3 plus 1 over 1 minus root 3 over 3. Good answer. It's just not going to be the answer. In order to put the top together, what do we have to do? Common. This 1 is over 1. This 1 is over 1. So in order to put the top together and the bottom together, I need to get common denominators. So I need to multiply the 1 by 3 over 3. This one too. So here I'm going to get root 3 plus 3, each of them over 3. And the denominator, I'm going to get 3 over 3 minus root 3 over 3. What can I do to them now? You have a common denominator for a reason. What can you do now? Common denominator. Why would you get common denominators? So you can put them, so you can add them, so you can put them together. So on the top, I'm going to get root 3 plus 3 over 3. Divided by, on the bottom, I'm going to get 3 minus root 3 over 3. Now I have a fraction over a fraction. That's just awful. Okay? If ever you have a fraction over a fraction, it means you have a fraction divided by a fraction. How the heck do we divide fractions? You're going to flip and multiply, correct? Are you not? So it's a lot easier to deal with fraction division when you have them side by side. So I would never leave them like this. I'm going to rewrite, because that just means root 3 plus 3 over 3 divided by 3 minus root 3 over 3. Does it not? If I read that to you as a statement, you'd go root 3 plus 3 over 3 divided by, you would write the division symbol, would you not? That's how you'd write it if I read it to you. That's how you have to write these. If ever, and in this unit it's going to happen a lot because you have to do proofs, if ever you get a fraction over a fraction and they're complete fractions, like these are complete fractions, right? Like I made them complete fractions. You have to make them complete fractions. Then you write them sideways. But in order to write them sideways, one beside the other, you need to make them complete fractions first. So you need to get common denominators and make the whole numerator one fraction and the whole denominator one fraction so that we can write it like this. Root 3 plus 3 over 3 divided by 3 minus root 3 over 3. And now you can flip and multiply. Now these cancel. And I'm left with root 3 plus 3 over 3 minus root 3. But what's my problem? You need to rationalize the denominator. So I'm going to get 3 root 3 plus 3 times root 3, which is 3 plus the inside. 3 times 3, which is 9. Plus the last 3 times root 3 is 3 root 3. All over 3 times 3, which is 9. 3 times root 3, which is positive 3 root 3. 3 times negative root 3 is negative 3 root 3. And our denominator middle terms cancel, and they should. If they don't, you didn't multiply by the conjugate. And then negative root 3 times root 3 is negative 3. I see phones out, but I'm not quite sure why, because it's really hard to write all of this ridiculousness that this question is whilst holding a phone. Yeah, crazy things. Okay, so 3 plus 9 is 12. What's 3 root 3 plus 3 root 3? 6 root 3. 9 minus 3? 6. And I'm done? What could I do? Take a 6 out. Yeah.
Would we be better off memorizing that? 1075?
No, because what if you get tan of a different version?
Well, yeah, but like, really.
I wouldn't. I would just learn how to do it. Because if they make a twist on it, and you memorize tan 75, and they give you any version of that, so they just need to give you a reference angle of 30. So they could give you 150 and 45. So they could give you 195. And that's tan 75, but has a negative in it. Because tan of 150 is negative root 3 over 3. And you memorized the positive version, so you get an answer that's not there. Yeah. Yes. Root 3 times root 3. So I'm going to give you some questions to work. I think this is the book. This isn't the full lesson either. This is just the start of this lesson. Yeah. So we finish the second part tomorrow. This unit literally only has 4 lessons. But it's not going to be 4 days because it's, well, not that nice. I really like this lesson, this unit, but you may not. Okay. So what's 7 times 180 divided by 12? Yep, that works. Number 8. So I literally want you to do number 8, and I want you to do number 8 well. And I guess number 7. I'm going to put it before it. Number 7 is 1 question. Number 8 has 6 questions. Only one of them is a reciprocal trig ratio. It's cosecant. So what are you going to do? You're going to find it for sine, work your way all the way to the answer, and then flip it. So cotan, I would just take this answer and 1 over that, and then I'd have to rationalize the denominator. So, yeah. So you could take it here and flip it, then rationalize and do less steps, but whatever. I would always just take my answer and flip it. Okay? So that's all it means. Now, the other thing I wanted to say too is f is sine of negative pi over 12, which is actually sine of negative 15, right? So if I have sine of negative 15, which is negative pi over 12, I ultimately just need a negative 15. So you could go 30 minus 45. So not ridiculous, right? At all. So I need you to do those really well, and I'm checking your homework this entire unit and probably till the end of time because I don't trust you're doing it. Okay. Didn't want to do that to 18-year-olds, but I guess I'm going to have to.